Year 6B, and our learning objective today is to sketch translations and reflections of a given function. There's some prerequisite knowledge for this. We have to remember what function is and the function notation. This is quite important here. Also, this is a higher only topic, so if you're doing foundation, you don't need to actually watch this video. So, and also, knowing what translations and reflections are, we do them in kind of a while down the road, but I'll briefly talk about what they are. But say we're plotting the function y equals f of x, right? And I don't want to be too specific about what f of x is, but let's say some sort of quadratic or parabola even. Say it's a parabola that looks a bit like this. And this is f of x on the xy plane. Now if I ask you to plot y equals f of x plus 2, now I haven't really told you what f of x is, right? It's not like you could, just change the equation and then, plug in the values and plot it, right? So how would you do a question like this? Well, the thing to realize is, right, if we're plotting y equals f of x plus 2, so that just means whatever x value is, we'll still get f of x, but what we'll plot is just 2 higher above, or y will just increase by 2. So this is clearly just a translation, with y being up by 2. So a translation of 2 in the positive y direction. So then it will just be the same curve, just moved up, right? So actually better to do it in a different color. So, instead of, say, this point being here, we'll have it 2 above. And same thing with kind of all the points. So, this instead of being here will be somewhere here, for example. So, maybe we'll have something like this. So this might be a translation of 2 up, right? So, everywhere we had f of x, we just added 2 to it. So y would just be up by 2. And if we had something like, y equals f of x minus 2, well, you can see it'd be the same thing, just moved down, right? So we just take this curve, we move it down, for example, like to there. Maybe a bit lower, actually. It's not the best drawn curve. Maybe if I'll get rid of this and I'll redraw that. So it might actually look a bit closer to this. So that's what we might say when it's f(x) minus 2. And this is a translation, right? And if you don't really believe me, let me open up Desmos and I'll show you that. So try to ignore what f of x says here. I've had to kind of put this in. If we're plotting, f of x, that's of course the same thing, plus 2. We'll see that just moved up by 2. Say, look here, it used to be minus 20, now it's minus 18. If we had, say, minus 2 as we had before, again, look, it just moved down from minus 20 to minus 22, for example, this point. And, it's the same with every point here. So you say this point, this was at minus 18. But we go vertically down, that's at minus 20 now on this curve. And, play around with Desmos just to kind of get a feel for this. Just put in f of x is equal to, any function that you can think of. And then in the next one, write kind of a translation you'd like. Now, let's think about if we maybe if I redraw this actually, or actually I'll get rid of this red stuff. Let's think about if we had, instead of doing y equals f of x, all minus 2, what happens if we were to draw, say, something like y equals f of x plus 2? Okay, well, this is a bit weirder, isn't it? So, we've replaced everywhere we had x by x plus 2. So, what's happening here? We're saying wherever we had x, we've got x plus 2 now. So if we're looking at the function, so we had x here, right? Wherever x is here, now we suddenly have x plus 2 there, which it takes you a while to get your head around. But if you think about this, what we're saying is that everywhere we had, so if we have, if in the new curve, right, wherever we have in kind of a new x value, right, we have to think about where x minus 2 is. So we have to think about, hey, when we had whatever we had on the kind of 2 to the left. So if we're replacing x by x plus 2, we're thinking, maybe if I actually draw this out even, f of, I'll get rid of this one here, f of x plus 2. So you can see it translates to the left by 2. And the way you might want to think of this, right, is, so if you think about this point here, right, it's minus 2.5 on the new curve. But if we plug this into the old curve, it will be at the value, the y value we're looking for is the y value at, x equals minus 0.5, because, minus 2 plus 2 is minus 0.5. So basically, because we have x plus 2, we think, okay, look, what value of the old curve do we want? What y value from the old curve do we want? So if we have, say, if we were looking at the value, say, I don't know, if it was, say, we zoom out a bit, if we go to, say, here at minus 7, right? We're at minus 7. We're thinking, if minus 7 correlates to x plus 2, what x value on the old curve are we looking for? Clearly, we're looking for minus 5. So we just plot the value it was at minus 5 at minus 7. And you do that's the same thing for all of them. You think, if I'm curious to see what for x plus 2, what the value at the x value at, say, I don't know, I can't find a nice one, say, minus 5.716 is, I think, okay, what's the x value on the old curve that I'm interested in? Since this is x plus 2, I'm considering then with, when we go to here, where it's kind of plus 2 then, which is minus 3. So we do whatever on this curve, we'll just add 2 to it. And then we'll get to the value we're interested in. So on the new curve, if we're looking at what's the y value at 2, we think what's the y value at 4 on the old curve, which is here 0, for example. So because of that, if it's x plus 2, we'll shift it to the left, or sorry, translate it to the left. And if it's y equals f of x minus 2, we'll translate it to the right. And in the general, the principle is, right, if we have y equals f of x, and we do say y equals f of x minus k, this is a translation, because look, it only affects the x-axis, because it's affecting the x thing here, right? It's going to be a translation in x, but it's going to be a translation of k 0. So because it's minus, we think it's going to be positive in the k direction. And if we have, say, y minus k is equal to f of x, then this is going to be a translation of 0k. So this is clearly affecting y only. So because it's y minus k, this is x minus k. This is affecting x. This is affecting the y. And since it's a minus, we just kind of ignore the minus and we say it's going to be a positive k. But if it was, say, y equals y plus k is equal to f of x, well, that's y minus minus k. So in this case, we have got a minus, it'd be a translation of minus k. So this is a translation of 0 minus k. And that's kind of the rule you have to remember. When it comes to translations, when we have a y equals f of x, and then we kind of transit, and then we have we plot the new one, f equals y equals f of x minus k. This is a translation, or even if I say this a bit more generally, we say y minus w maybe equals f of x minus k. This is a translation of kw. And if, say, if w is positive, then we do minus minus. So if it was plus and plus here, we'd have a minus and minus there. So that's how we deal with translations. And if we have y equals f of x, and then we suddenly do y equals minus f of x, what does that look like? Well, that's saying wherever we had x, right? For wherever value for x, instead of having the value we currently have, we're going to have negative that value. So we're going to have negative this value, so that will be up here. Same thing with all of these. And when we are up here, for example, we'll have a negative this value, so we'll be down there, for example. So you can kind of tell that's just going to be a reflection of the y-axis. So it looks something like this. And I'll plot that here. Y equals minus f of x. And you see, look, that's just a reflection there in the x-axis. Or kind of, as I like to think of it, in the y direction. So you can see that, well, another way to write this is that minus y is equal to f of x. And you can see that this is only affecting if it's affecting the y, then it's going to be in the y direction. And then by the same intuition, if we apply this to the x one, well, it's a reflection in the x direction, i.e. in the y-axis. This is the y-axis, but I think of it as in the x direction, if you get me, like along that horizontal direction, that's a reflection which is in. So it's affecting since this is affecting x, not y, the minus sign is in here, not out there. it's inside the bracket, so it's affecting the x. It's a reflection in the x direction, which means the y axis. And if the minus sign is up there, it's affecting in the y, so it's in the y direction or in the x axis. And that's how you deal with translations and reflections. We'll walk through a few worked examples now. On a separate diagram, sketch the following transformation of the curve y equals f of x. On each sketch, label the coordinates of the turning point. So this is the curve y equals f of x, and we have to do this translation here. So the thing with these is you should do it kind of step by step. There's clearly two translations here, right? And also when it comes to these, rearrange it so that everything either affects a y or is inside the brackets affecting an x. So if we say a, we rearrange it as y minus 3 is equal to f of x plus 1. So now everything is either inside a bracket affecting x or out, next to the y affecting the y. So this is, we know, a translation. If you can just pause the video, think about what the translation is. Of minus 1, 3. And you just sketch this, right? So you'd go down by 1 and then, go to the left by 1 and up by 3, right? So the coordinates of the turning point will be then, well actually I may as well sketch it, right? So minus 1 this way and then 3 up. So the turning point will be somewhere over here. And then it's important to get these correct where the, the station you might struggle to find where the new roots are, for example, but just kind of the turning point will be the one that kind of stays the same, or not stays the same, but you'll be able to work out through the translation, and that's why I asked you to label it. So it's going to look like something like this, right? And then you can say the turning point will be at minus 2, minus 1. Because if you translate this by minus 1, 3, so the x coordinate will go 1 to the left, so minus 1, that, so minus 1, minus 1, minus 2, and then minus 4 plus 3, minus 1. So if we, I'll work through, say, the odd ones, and if you can try, work through the evens as well, so the b, etc. So I'll do c and e as well. So c, how will this look? So y equals minus f of x plus 2. So again, as I said before, let's make sure everything's in kind of either inside a bracket affecting x or outside affecting y. So we do c. Y minus 2 is equal to minus f of x. So minus y plus 2 is equal to f of x. So in this case, this is a bit weirder, right? What order do you do the transformations of? Do you do a reflection first, then a translation, or a translation, then a reflection? And I guess it's kind of, it's almost based on preference. So if you think about it, right, if we do the reflection first, if we have y equals f of x, if we do the reflection first, we're going to replace y with minus y. And then if we do the translation after that, we're going to replace y, so it might be minus y minus 2, right? So we replace the y by that, and the y is still being times by minus y, right? So this comes out to minus y plus 2, which equals f of x. So you can see that we do a reflection first in the kind of y direction, i.e. in x-axis. So this is a reflection in x-axis, followed by this translation, right? Because this is how you're affecting y. You might think there's a plus here, for example, so you think, oh, it's a positive translation. But that doesn't really work out, that doesn't really make sense, because you affect y fully, right? So then you say, and then translation by 0, 2, if you want to do it like this. Or you could do in the opposite order. You go y equals f of x, y plus 2 is equal to f of x, so translation by 0 minus 2. And now you go minus y plus 2. So remember, the reflection will only affect the minus y, right? F of x. So then reflection in x-axis. So you can do it either way, but just make sure if when you reverse the process, you actually change the translation. So you have to watch out for that. So I'm going to do it this way. I find it easier to reflect first, I think. But this is just personal preference. Get rid of this. Okay, let's reflect first. I actually sometimes draw this out in two separate stages. So reflection will look reflection. Of course, we'll go through the same. These points will be the same, right? Reflect, and what will the turning point be? 1, 4, and now translate by 0, 2, so up by 2. So now if we kind of move up by 2, what will that look like? So this point will be here, that point will be there, right? So it will look something like this point is up, yeah, sorry. And then it'll be at 1, 6. If we do the final one, f y equals, let me actually, sorry, increase the thickness of the pen so it's a bit easier to see. Y equals, what is it? F of minus x plus 1. So again, let's rearrange it so everything's affecting y or x. So just try rearranging it. So either inside the bracket or affecting y. So y minus 1 equals f of minus x. And how would we do this? The reflection and translation, we have to be careful of order. In this case, it doesn't really matter because x and y are being done independently. So there's a translation in y alone, and it doesn't affect x. And there's a reflection in the kind of x direction alone, which doesn't really affect y. So it doesn't matter which order we do it in. So this is a translation by 0, 1, because they don't affect each other, right? So this is y only, this is x only, so it doesn't matter with order. Whereas here, the order did matter a bit more. So translation by 0, 1, and reflection in y-axis, which is the x direction, right? So if I go ahead and delete this stuff before, this again, it doesn't matter kind of the order, so I'll translate first because that seems a bit easier in this case. So translate up by 1 and then reflect in y-axis. Or maybe we can. It doesn't matter. It's completely optional on choice-wise. Which one you do first. That and then reflect in the y-axis. So it will look something like that. So when we translate up, we get to minus 1, then 3, and when we reflect, we'll have it as 1. So 1 minus 3, and that's our new coordinate for the turning point. So these questions can actually be fairly tricky, but the way to approach these, first remember kind of what the translations and reflections look like, and also then isolate them in terms of y and x. So either make sure that everything's inside the bracket, so rearrange it, so they won't necessarily give it you to the nicest way, but rearrange it so that everything's either affecting x or everything's affecting y, and then work from there. And be careful with the order. So sometimes if you want to check the order, do what I did here, and then just walk through it. So if I say, I look at this and you can kind of figure out that there's some reflection and some translation, right? So you say, okay, let me just pick one, let's do it first. This is what it looks like, and in order to get to this equation, from even that way, not there, it should be pointing that way, to get from here to here, and I remember after whatever I do to y will be kind of times by a minus because I've already reflected it. So I do minus 2 like this, and then so I can get to that equation. We've got another question as well. The diagram shows the part of the curve y equals sine x. The coordinates of one of the maximum point is labeled A. Write down the coordinates of A. If you know what, we talked about this in the last video, so this will be 90 and 1. Kevin wishes to translate the curve by 5 units in the positive x direction. Write the equation of the translated curve. So we want to translate, so I usually write this, out translate, and 5, 0, right, in the positive x direction. So what you'll have to do is you'll have to replace x by x minus 5. So I say x goes to x minus 5. That's what I do. This sign means replace what's on the left with the right. Replace x with x minus 5 if you want to translate like this. So we look at the function y equals sine x. We replace x by x minus 5, so y equals x minus 5. And there we go. That's kind of it. So hopefully everything in that lesson made sense. It's a bit of a tougher thing and kind of a bit harder to do. And when I was learning GCSE, I don't think this was actually in it. I actually learned this at A level, so it is a tougher topic in my opinion. So please, practice some questions on this. The more questions you do, the easier it will get. So hopefully that made sense, and I'll see you guys in the next video.